Hello, Mr. Corliss. I'm Ethan Lee, and the piece of work I want to analyze is the CER we did 2 classes ago on the figure of the groups and the flowering time. So the first thing I want to do is I want to revise a mistake that I made. I initially thought that plasticity was present in this figure because, as you see, in the high treatment plants, the flowering time is lower than the low treatment plants for both the arboretum and back bay, the wet and dry sites. So I thought there was a difference that was created in the plasticity. However, my mistake was corrected in the last class by Emmy, who told me that because the error bars overlapped and because they overlap in both the high water, low water, arboretum, and back bay treatments, that it was a negligible difference. And this was quite enlightening to me because that was the only thing that was leading me to believe that there was plasticity present. But after that evidence, I realized that there was no plasticity present, and I did recognize that um, because of the difference between the 1997 and 2004 plants, that adaptation did happen in the arboretum and the back bay as well. And at first, it was puzzling to me why the low water treatments had a longer flowering time than the high water treatments, because I thought that the high water treatments would want to flower later because it did not need to escape the drought, whereas the low flower treatments would need to escape the drought. So it made a lot more sense to see that the plasticity there was negligible. And this was further supported by Table 1, which showed that because the treatment had a random p-value, that it meant that the treatment showed no correlation with plasticity. So plasticity was not present, whereas for population and generations, that shows because there was a correlation. That means that there had to have been some sort of evolutionary adaptation there. And I would like to bring you to my second part of this process letter, which would be um, connecting this to something else in my life. And I want to connect this to my tennis tournament, which I just played this weekend. And I had some very long matches, and I was very tired. But I was still thinking about biology, of course, because I love biology. But what I was thinking about is because I was so tired in that moment that I couldn't play to my normal ability. So what I tried to do is I tried to shorten my swings, tried to take some shortcuts with my footwork, and I tried to serve the ball harder in order to end the point quicker and conserve more energy. And this would be an example of plasticity because I am using my previous skills to try and adapt in the moment. So while I would play one way when I'm energized, I will play a different way. This is the same as like high water or low water treatments. However, I do show a difference. I am plastic, and so while in high water or high energy situations, I would want to like play long points to try to grind out my opponent. In low energy situations, I want to end the point quicker and take shorter swings and try to hit more winners. And this also reminded me, like, I started thinking, what would like an adaptation, what would evolutionary adaptation be? And that would be actually training your own game. So while I play a different way, while I play a different way when I'm low energy, I still train the same game over a long period of time. And that is through like just grinding footwork or strength training, but also just practicing my forehand serves, backhands over a long period of time. and there are trade-offs here, which also remind me of one of our previous assignments, and the trade-offs are if I'm always in these plastic situations where I'm low energy or high energy and I'm always needing to switch in between these, the conditions are always changing. It's hot outside, it's cold outside. I'm playing on grass, I'm playing on clay, I'm playing on hard court. My conditions are always changing. That means that my my evolution, my adaptations won't be similar over a long period of time. It's like connecting this back to the plants in our paper. It's like if it wasn't a drought between 1997 and 2004, and it was just on and off drought, some dry areas, some very wet areas. That means that the plants would not have adapted the way that they did. They would not have a shorter flowering time after those 7 years, and that is the same for tennis. If if I'm unable to train my game in a specific way over a long period of time, and there's always changing conditions, then I won't be able to lead my adaptations towards one way or another, leading me like confused. Same as the plants. All right, that's all I got. Thank you, Mr. Corliss.